Hello and welcome to NICER 201, online course on causal inference from observational studies, CAUSIT. We're talking about confidence intervals, and in this session, I'll talk to you about some of the misinterpretations of confidence intervals that we find in literature. Sometimes it is said that the specific 95% confidence interval presented by a study has a 95% chance of containing the true effect size. That's not true. Why? Because one particular confidence interval will either contain the true effect or will not contain the true effect. And we don't know whether this particular confidence interval that we have estimated from our study is the one that contains the effect or does not contain the effect. Also remember that the word 95% here refers only to how often the confidence intervals, if you had calculated confidence intervals from multiple studies for the same objective and the same study and same design and everything, how often would these total number of confidence intervals, how many of them, so 95% of them would contain the true effect size, of course, assuming that all the assumptions are correct. It is also not correct to interpret that an effect size outside the 95% confidence interval has been refuted by the data. Remember that this can happen due to violation of any of the assumptions that we use to calculate the sample size. As with the p-values, remember that the confidence interval is also computed using many assumptions. It also depends on how the study was done, how the samples were collected, and so forth. So violation of any of these assumptions could have led to the results that we are seeing in our study, and it may not actually be, maybe the true value is actually outside of this 95% confidence interval. Of course, we will never know about it, and hence it is not appropriate to interpret that effect sizes outside this confidence interval are excluded by the data. Sometimes you will see that it is said that if if you have two studies or two groups, and if the confidence intervals of these two groups overlap, then the difference between these two studies or estimates is not significant. That may or may not always be true, because if you have to compare between two groups, you need to directly apply statistical tests to identify whether point estimate that you're getting from these two studies or these two estimates are actually similar or not. What is generally seen is that if two 95% confidence intervals fail to overlap, if they don't overlap at all, it would imply, and if you calculate the p-value for that, for the difference in the confidence interval, for the difference in the point estimates from these two studies or these two groups, the p-value would also be less than 0.05 for this difference. So for example here, if one group had a risk ratio of 2.5 with 95% confidence interval of 1.3 to 3, and another group had 4.2 with a confidence interval of 3.2 to 6.3, you can see here that these two confidence intervals, 1.3 to 3 and 3.2 to 6.3, they are not overlapping at all. And hence we can conclude possibly that 2.5 is actually different from 4.2. However, if you see that one of the confidence intervals contains the point estimate from the other group or the other study group, then when you calculate the p-value, it would be more than 0.05. So you could have a situation where, again, if we take the same point estimates of 2.5 and 4.2 from the two studies, maybe in another study, the confidence interval around 2.5 could be, let's say, 0.8 to 4.7. And for 4.2, if the confidence interval could be 2.8 to 6.3. Now, as you can see here, the point estimate of 2.5 from the first study, it actually doesn't lie anywhere in the confidence interval for the second study, which starts from 2.8. However, if you look at the point estimate from the second study, which is 4.2, it actually lies the first confidence interval between 0.8 to 4.7. And hence, you could infer that these 2.5 and 4.2 are not statistically different from each other. But it's also possible that you could get a situation like the second example here, where for the first study for 2.5, you have a confidence interval of 0.8 to 3.9. For the second study, where you have a point estimate of 4.2 for risk ratio, you get an interval estimate of 3.1 to 8.5. Now here, neither of, so 2.5 doesn't fall into the confidence interval of the second study, and 4.2 doesn't fall into the confidence interval of the first study, although the two confidence intervals are overlapping. In such a situation, just looking at the rest by comparing the confidence intervals, it is not possible to come to a conclusion whether these two values of 2.5 and 4.2 are similar or different from each other. We need to actually use a statistical test to identify whether they are different or not. Sometimes, again, incorrectly, it is stated that an observed 95% confidence interval predicts that 95% of the estimates from future studies will fall inside the observed interval. Just to remind you again that the observed interval from one particular study either will contain the true effect or not. And again, this 95% is referring only to how often 95% confidence intervals. We have multiple confidence intervals. How often the 95% confidence intervals computed from multiple studies would actually contain the truth. And finally, it's again wrong to interpret that if one 95% confidence interval includes the null value and another excludes the null value, then the interval which excludes the null value is more precise. People all say one is statistically significant, the other is not. So we would take the one which is statistically significant. Again, that is a misinterpretation. Remember that precision is not based on whether the null value is included or not. Precision of a statistical estimate is based on the width of the confidence. So let's take an example here. So if you consider two 95% confidence intervals for a risk ratio, let's say one has a limit of 1.5 to 13.5, and the other confidence interval has a limit of 0.6 to 2. Now, which one of these is more reliable? The first confidence interval, which is 1.5 to 13.5, it excludes 1, right? The null value if this is for a risk ratio, so it excludes 1. So although it says that there is a definitive positive effect, but remember that this is pretty wide. It's almost like it's 12 units wide, 1.5 to 13.5. So which means it is less reliable. Whatever is the point estimate that we would have got for the risk ratio is not reliable from this study, although it shows a definitive positive. And that could be because of the smaller sample size that may be there in the study. In the second study, where we have the confidence limit between 0.6 and 2, which is pretty narrow, although it contains the null value, but it is actually half as wide as the first one. And therefore, this second confidence interval of 0.6 to 2 is much more precise and reliable than the first study, which means that in the second study, the sample size is adequate or definitely much larger than the first study, and hence whatever results we get from the second study would be more reliable compared to the first study, irrespective of what the actual values are there, which we estimate from both the studies. Thank you.